Hi, this is Josh Rappaport with Singing Turtle Press, and today I want to show a shortcut for solving proportions. So first of all, let's just talk a little bit about what proportions are. Well, proportions are what you have when you've got two fractions, such as these, 12/20ths, equal to another fraction. So you've got 9 over x. So you've got two fractions equal to each other, and one of the fractions has a variable in place of its numerator or denominator. Here it's in place of the denominator on the right fraction. What you need to do, of course, is solve for the variable, solve for x. Now what I found through my tutoring is that most students know one of the things that you can do to make this an easier process, but they don't know the second thing. So what I'm going to do is first show what most people know, and then show what, in addition, you want to know so that you can make this easier. What most people realize is that they can cancel before they solve the proportion, and you cancel vertically. So for example, here you could say, well, there's a number that goes into both 12 and 20, and the largest number that goes in would be 4. 2 goes into both, but that's a smaller number. So if we use 4 going into both, we cancel out the 12, make it a, let's try that again, make it a 3. Cancel out the 20, make it a 5. So now if we rewrite what we've got 3 over 5 equals 9 over x. Now at this point, what most people do, because you can't cancel this fraction anymore, is they multiply. So they just cross multiply, that is. And when you cross multiply, essentially what you're doing, I'm going to use a little color to show this. What you're doing basically is you're kind of looping the terms that are diagonal to each other. So you've got the 3 and the x. I just colored them in red, and now I'm going to take this color here, they call it blueberry on the screen, and I'm going to loop the 5 and the 9. And the reason I do that is that the product of one pair of diagonal numbers equals the product of the other. The product, of course, is the result of multiplication. So I start with the diagonal that has the variable, that's the red one, and we'd say 3 times x equals the other diagonal, the blue one, 5 times 9. And that's just the same as saying 3x equals 45. And at this point, of course, it's just simple algebra. You just divide both sides by 3, and you wind up with x equaling 15. And that is correct. There is absolutely nothing wrong with that. Okay, but what I want to show is that there is another thing you can do, another step you can take. So we're going to start with the same basic proportion. 12 is to 20 as 9 is to x. And this time what I'm going to tell you is that not only can you cancel vertically, you can also cancel horizontally. In other words, you could cancel potentially the 12 here with the 9. And you can cancel in whatever order you want. You can cancel the 12 with the 21st or the 12 with the 9. Doesn't matter. There's a way I like to show this, which is as follows. I take the variable, and I draw a little diagonal arrow with it. And then that goes to the 12. I like to put a little box around the 12. Because what I'm saying with that is that the 12 is in a sense the magic number. It's the number that can cancel both ways, okay? And I'm going to stick with this idea here. I'm going to cancel first actually the 12 with the 9. 3 goes into both. So 3 goes into 12 4 times, and 3 goes into 9 3 times. Now, here's an interesting situation. The numbers 4 and 3 are just 1 apart. Whenever numbers are 1 apart, there's no number that will reduce both of them. There's no number that will go into both, except 1, which doesn't help us. So these two are done with respect to each other, the 3 and the 4. However, we can still cancel this 4 with the 20 because two different numbers go in, 2 and 4. 4 is the larger of the two, so we'll use 4. 4 goes into itself once, and 4 goes into 20 5 times. Now, whenever you get 1, here's another special thing to know. It's done. It can't cancel anything else, and since 1's in the place of the magic number, it's diagonal to the x, that means there's no more canceling to be done. So at this point we go ahead and we cross multiply. Well, actually first, I'm going to rewrite the problem. Now we've got 1 is to 5 as 3 is to x. And I like to think of these numbers we get at this point as like the survivors of the battle. There's almost like all this violent stuff going on with slashing and reducing here. But here are the survivors of the battle. We'll use the same colors to loop them. So we're going to loop the 1 with the X. In red, we'll use the blueberry color here to loop the 5 with the 3. Okay. And then I'll go back to my little maroon color to show what we've got. Well, with the red diagonal, we've got 1 times x, which turns out to be a really nice thing for reasons you'll see in a moment. 1 times x equaling the other diagonal, 5 times 3. Now, what makes 1 times x so nice? It's that 1 times x is just x. Okay, so whatever we get here on the right side of our equation will be the answer. 5 times 3 is 15. And that's the answer, x equals 15, which agrees with what we got the first time. But you see that when you do all the canceling possible, as we did over here, because we canceled horizontally as well as vertically, when you go ahead and do your cross multiplying, you get straight to the answer, and that's a really wonderful thing. So I would encourage you to go ahead and use this process, canceling both ways, and it will make solving proportions just so much easier, I guarantee you. So, well, basically that's it. That's the shortcut. It's just a nice thing to know. So try it and enjoy it.